do we have a conjecture for what's happening?
What the result is, or why?
Or whatever you're seeing, the explore part?
Yeah, the sum of the lengths will be half of the sum.
Sum of the pinwheel is half of the perimeter.
What is
This little pinwheel around segments. So, the question becomes, can we prove that?
At the moment, I could pretty much say that.
Well, let's try. Let's try for just a triangle. So let's pretend like we have an equilateral triangle. So ABC is equilateral. And we put a point inside here. Call it D. And then I found perpendiculars to the edges. And we mark these points. And let's call them X, Y, Z. So, if we want to rewrite our conjecture, symbolically, what would our rewrite be?
CZ plus BX equals
1/2 AB plus BC plus CA.
So we're trying to figure out whether or not this is true. All right. I'm done.
How do you prove?
Okay.
I'm done. Talk to me about some things that you know from the picture.
I could draw line from D to A, and D to B, and D to C. I'm gonna get. This triangle is sort of congruent. Oh no, wait.
No. Side angle. It doesn't always. You need a side. Another angle.
Is it not? On here, they're, you know they're congruent.
So it kind of, I mean, they kind of look, for example, the ones on the left here, the XDA and XDB, those look pretty congruent.
Yeah.
But these don't look so congruent, and these don't look so congruent, and these possibly could be congruent, but I'm not quite convinced of that. But I think, you know, drawing these pink lines, or line segments, that may be the key to what we need to do next. Because what we're doing is now we're introducing new triangles that we can say new things about. So now with this new picture that Roxy's provided us, what new things can we say? kinds of triangles do we have here?
That's awesome.
Right triangle.
We have right triangles, right? Right triangles have lots of special properties. And I'll bet that the reason why we did perpendicular bisectors, why I didn't just like draw anywhere, is that right angle has probably got to be important to this, making these right triangles. So what can we say? What can we say about the picture at this point?
The area of each of those triangles is 1/2 the side plus the, or times the height, which is the perpendicular.
Can you write what you're saying, Kelly? Because I can't follow your words. Do you believe that statement? Those statements? Okay, all right. So there's something new that we didn't have before.
It's the.
Well, the AB, AC, AB, BC is from above,
And we can find the area using.
and the 1/2 is in there. The right side of the top equation is 1/2 AB, 1/2 BC, 1/2 CA, which is in the bottom.
Do you understand what Kelly's saying?
That's how you get the 1/2 in there. For sure. Add them up and set it equal to the whole
The
area.
area of the whole thing.
Which is what, one.
So
Still thinking.
you're all everybody needs to know what's going on. So what were you saying?
Let's see, I was saying, oops, let me see. I think Kelly said, triangle. So the area of the entire triangle is equal to the sum of the 3 areas of the 3 triangles.
Is this all right, everybody? So we have nice expressions for the areas of each of these that we can substitute in. What's the algebraic expression for this?
1/2 area.
Square root of 1/2 of the semi-perimeter.
Square root of S.
That's a 30, 60, 90 triangle.
We can do, can you do the formula?
What is what form?
Square root of S.
What
it's square root of s times s minus a times.
Six S
It'd be the
equal
square root of
AB plus BC
Please don't tell me you have that memorized.
CA.
Divided by 2.
We could prove it.
What?
And
Why
then-
do you have that memorized?
So the area of that would be S times AB minus, what is it?
S minus AB times S minus.
What the heck?
Oh, and then
You don't like Aaron's formula? This is Aaron's formula.
that,
But then you have to introduce the square, so I don't think that's.
S minus just make me times S.
Why don't we just
Yeah.
why don't we just this is
Three,
Right.
square root of 3 times a over 2 is the height,
square root of 3
Times
times a over 2
a over 2.
is the height.
Yes. That's the height. So the
So
area
Is 1/2 of that times a.
Okay.
yes.
Or square root of 3 over 4.
Yes.
you're still getting it squared.
Yes.
That's true.
Or,
And all those sides are the same, so you could essentially just pick one thing, right? And name them all the same thing.
Yes. And I mean, I guess we called it A.
Right. So just call it A.
So this would be square equals 1/2 a times dy plus 1/2 a times
Yeah.
yes, thank you, plus 1/2 a times
Easy.
And factor out the 1/2
I am not your little monkey.
Oh.
Divided a's from both sides, then you wouldn't have the square, right?
As long as a isn't 0, we could divide both sides by
And then there
a.
would be a triangle.
Then there wouldn't be a choice. So I think we're okay with doing that. So,
I thought we pulled the 1/2 out too.
We did.
well, can we divide both sides by 1/2?
Yeah.
Multiply by 2.
But then you're changing it from a 4 to a 2, and you already did that.
You're right, yeah.
You can't do that. You have to put the 2 back.
Yes.
yes, yes.
Oh.
It was a 4, and then you already
Oh.
did
Square root of 3
another.
over 2.
Okay. dy plus dx plus dy.
Okay.
3 times a divided by 2. That's what we want, the square root of 3.
The unfortunate thing is now we've lost Kelly's idea of, oh, we had A, B, B, C.
That's what
Right.
we did.
But that's the dy, dx, dz.
Yeah. Yeah. But we don't want, in the end, we don't want dy, dx, dz. That's nowhere in our final state that we're looking for.
1/2, can you substitute, because that's the same from 1, right? So, what's that?
This does tell us something really interesting, though. This tells us that the sum, so what does this tell us? What are these?
Altitude. Those are all the heights.
Those are all the heights, those are these altitudes of this triangle.
Added
When we
together
add them
equals the
together,
whole height of the triangle.
yeah,
We
it
can
equals
make
the height
them
of the triangle. Ooh,
Wait. How do you know their altitudes?
because they're
They're
We
perpendicular.
divide them.
To a point.
No, they're
Yeah.
perpendicular.
perpendicular to the
But
line.
she's thinking altitude of the whole triangle should go from B perpendicular to the side. She
Yeah,
was thinking
it's not
that
coming
altitude.
from B, it's coming from
Right.
Z.
And this is the altitude of this triangle.
Oh,
Oh, okay.
This is the altitude of this
okay, I
triangle.
thought
This
you
is the
said.
altitude. So the sum of the altitudes of the individual triangles equals the altitude of the whole triangle. Oh, so this is something new that we had. Sum of altitudes of original. Sum of altitudes of 3 subtriangles equals the altitude of the original, no matter where that point is,
If it's equilateral.
if it's equilateral.
But we made it equal.
Right. So that's kind of interesting. So this,
So wait, that's
So-
over there.
so the sum, so these 3 sum, so the sum here plus here will always be constant. It's fixed according to whatever your triangle is.
This is square root of 3 over 2a squared, right? Or, no, it's just 2a squared. And this is 1/2 ac times the
Just call it A.
Oh, yeah. So you roll that out.
Hey, Kel, I think you have an extra one in there. You got a little
One
extra
half.
something.
Oh, yeah,
something.
you're right.
It's okay, just erase it.
One half x But that's what we had before.
Yeah, but that's now the height of the whole triangle, right? Because so that's,
This?
no, dy plus dx
Oh,
plus
yeah,
dz
this is the height of the whole
is
triangle.
square root of 3 over 2a. But that just proves that there, yeah.
That just proves
It's
that
the
half
same.
equals a half.
Yeah,
Because
right.
everything's in common.
Yeah.
And this should be.
Yeah.
4, yeah, you're right.
So yeah, left hand equals the right hand.
Great.
Yes!
We're done.
Woo!
Let's go home.
We're done.
So, although we found something interesting that we've been able to prove, maybe this approach is not the best approach to try to tackle this. I mean, it got us something really interesting that we were actually able to prove that wasn't our original statement. So, let's try to look at it through a different lens as opposed to, and this is what's really hard for students, you need to now divorce yourself from the ideas of areas. Because that started us down this path. Let's examine this again, think about right triangles, and attack it from a different perspective rather than, oh, if we've got these right angles, I can find the areas. Are you all with me? Okay, so let's,
That means is there a squared plus b squared equals c squared?
Sides.
Yeah, the sides. Think of the sides, because that's what we're trying to look at, is the side lengths.
so you're thinking now,
Proportion.
look at
Look at,
Pythagorean theorem ideas.
maybe.
So, for
Like
example,
Triangle ABY.
right here,
Yep,
that's a right triangle.
yep,
And we want an AY somewhere.
right.
So we've got AY squared plus BY squared equals AB squared. Alright, now I really like a CZ somewhere. I really like a BX somewhere. fact, we've got 1, 2, 3, 4, 5, 6 right triangles. So let's just put all of those up there and see if it helps. Alright, so I will do this legwork for you.
Thank you.
What are y'all thinking of doing? What are y'all thinking to do? What's going through your head?
I'm not sure if it'll help, but I'm thinking, AY plus YC is equal to AC, so adding the segments together. But we're gonna need that AC eventually, as well as AY. And then the other two. So the.
Anything strike you about something you can do with these?
Some of them are equal,
Mm-hmm.
so triangle,
Like these two.
right,
You could say cy squared plus dy squared equals cz squared plus dz squared. Which, if I add the left-hand sides together and add the right-hand sides together, that should make equivalent sums. And notice the dy squareds, the dx squareds, the dz squareds would all drop out.
Yes.
Yes, no, how? So see if you can take it from there with this, and I think you should be able to prove it with those. Because now we've gotten rid of information that we actually don't want to remove.